Well, hello, everybody. We are going to be going through the how well do I know this from section 2.2 because I'm going to be going. So this is going to be your key. I'm going to actually post the answers on here for you to be able to look at it. You're going to have this to work on in class. And if you need to watch this, I will go through each of them so you can fast forward through whatever it is you're going to need. I will try to talk about how each of these things work as I go, and we'll do our best. So I'm just going to keep going through this talking. If you get to a place where you've got a question, I'm not here, so don't ask. Okay, here we go. Graph of G is shown. Write an equation for G. Anytime that I've got something like this, where we have just straight up uh, the vertex at all, we're going to use vertex form. Formula for vertex form that we had before is y is equal to a times x minus h squared plus k. Okay. The whole point of everything that we did for this was basically if it's something that has a vertex on the axis itself, we're not going to have a k value generally. And if I've got this x minus h squared part, it's whatever this number is going to be. So if my vertex here is -5, 0, then it means that this part is going to be x plus 5 squared plus 0, so I don't need it. And then I could look to be able to sort of see where these things are going to be going. But if you do remember, if I look at where these points are, if I've got a 0, a 1, and a 4, generally those tend to be the things where like I'm not actually doing a multiplier. So y is equal to x plus 5 quantity squared is fine because of our points. Now it also said write an equation for G. So in a case of something like this, I could have put the a here and just say a times x plus 5 squared, but because these points work, I'm fine with everything that I have there. That is the value that we have, x plus 5 squared, which we remember when we have something that's a perfect square, it means that that point is going to be on the x-axis, which is perfect here because we're talking about the following does not have a vertex on the x-axis. So basically, I'm looking for something that is not written as something squared. Okay, well, this first one, x plus 2 times x plus 2, that's a squared. So this is a no because that would be on the axis. This is x minus 3 squared. Nope. Okay, that one is not factored. This one, though, we would have a 0 at -4. We would have a 0 at a +4. That means it's going to cross at two different places. Definitely the case. And I will tell you that if we factor this, it is going to be x and x, 4 and 4. So x plus 4 squared. So it's not going to be that. That's going to be our answer. All right. Now, here's where we start to get to the place of doing that diagram to complete the square to figure out what it's going to be. So here's the way that we kind of work with that. In the case of this, x squared minus 16x plus 64. So if I'm going to just do a diagram to look at what it's going to be, here will be our x squared. Now, for that minus 16x, we have to split it in half, right? So I'm going to have half here and half here. So this will be, well, if I think about this, this divided in 2, we'll have a -8x on this side. We'll have a -8x on this side here. So x, x, -8, -8. If I look at what I would then need to complete the square here in the corner, this would be the same as the -8 times the -8 as we go through, or a positive 64. Now, fortunately, that's literally exactly what I have. So I already have the perfect square right there. Written as a square, this will be y is equal to x minus 8 squared because of the fact that I've got x minus 8 times x minus 8. So if I'm going to write the vertex in this case is going to have the value of 8 for my x value because I could plug that in here and get 0. And because I'm not adding up or down, it's going to be 8, 0. Again, anytime I have just a perfect square with nothing extra, it means that I'm going to have a vertex on the x-axis. Does the graph of this have a vertex on the x-axis? Okay, so we're essentially doing this, seeing if we have a perfect square. And if we do, it does. And if we don't, it doesn't. All right, cool. So I'm going to start doing these a little bit faster as I go and just making this. So I've got my x squared here. I'm going to split that 10x into a 5x and a 5x. So I'll have an x and a 5 and an x and a 5. That means that down here, I would need to have a 25 for it to be a perfect square. When I look there, I have a 21. So what this means is that I am 4 short of what I need. So if I'm 4 short of what I need, because I needed 25 and I've only got 21, I can say not on axis, not perfect square. What I am going to do, though, is to show you, if I know that I'm 4 short, I know what I can end up doing with the fact that this is going to be the case. I can actually write this then as an x plus 5 squared, 4 short of that. So it's minus 4. So if I did want to actually say what the vertex is, because I'm 4 short, I'd have to keep count of that by the 4 short here. And I could say that the vertex is actually -5, comma, -4, which is not the x axis. Either of those ways is fine. And this is a way to do it that is going to let you actually show the work as to what's happening. And we're going to be doing this enough that I feel like you guys are going to be fine. Okay, next page. Now, in vertex form, in vertex form, in vertex form. Okay, so let's just start by doing this. I'm going to really quickly make my little boxes just to see what I've got for both of these, because they're just an x squared, and that's nice. So we'll have an x squared for both of them. Love. Okay. This one, because I have a number there, I am going to have to think about that and talk about it, but these should be pretty quick. So now, because I've got that -12, I'm going to split that. So if I divide that by 2, we're going to have -6x here and -6x here. And that means then that on the outside of this, we'll have x. This will be a -6, x, and -6. That means that what I'm going to need here, -6 times -6, I need a 36. All right, cool. Now, in this case, I've got a 43, which is more than I needed. So the question is, how many more is that? So right now, that splits with a 36. And then in this case, it is going to be 7 more than I needed, or 36 plus the 7 to get me where I'm at. What that means then, if I'm going to write it in vertex form, is that I've got the x minus 6 squared. Got that 7 more, so I'll do a plus 7. And that is going to be a y. That is my equation in vertex form. Yeah. All right, here we go. Now, this is going to be really interesting to see what it is that we have to do. Because as we're doing this one with the negative is going to be a little bit painful, but that's fine. Okay, so I got to take this one and divide it by 2 to figure out what I'm going to have on the top and the bottom. Now, 13 divided by 2 is actually going to be 6.5x for both of these. Also fine, no problem, 6.5x, great. So if I'm doing 6.5x and I take those out, we have x, we have x, we have 6.5 and we have 6.5. The question is, what am I going to have down there on the bottom? So if I'm looking at this, if I do 6.5 times 6.5, I'm going to get, I need a 42.25. Okay, I 100% do not have that when I have a -10. All right, so if that is the case, I am short a lot. Short, well, let's figure out what we would do. I need 42.25. So I'm short 42.25 and 10, because this is already a negative. So I would have had to have filled this hole anyways. So in this case, I'm minus 52.25 from where these things would have been before, because I don't have any of that and I've got the negative. So I have to put them together. Okay, that kind of talks it out in terms of what I would need then. So with that, my equation itself would be that y is equal to x plus 6.5 squared from what I have down on the sides here. And then I've got to keep track of this short amount by minus 52.25. It's not amazing, but it does work. Now, I freaking love this. So here's what we're going to do. First thing, when you look at these, what I'm going to do first is recognize that -15. We're going to put that guy off to the side. We're going to have to deal with it at some point, but I'm not worried about it yet. Okay? Let's talk about what we're going to do here. Because of the fact that I have 2x squareds, That 2 tells me that I'm going to be making 2 different diagrams, one with each of the x squareds, because essentially what you're doing is you are building a single x squared for each of these. Great. Now, however many of them I have is the way that I have to divide this up to figure it out. So because I divided this into 2 groups, or whatever number's in front there, I'm going to split this into 2 groups. So I've got 6x to divide for this one, and I've got 6x to divide for this one. Now, just like I did with the other one, since I'm making an individual thing, I am going to take that divided by 2 in both cases to figure out how many I'm going to have on each side here and here. 6x divided by 2 gives me 3x there and 3x here. And then I've got the 3x here and the 3x here. Okay, that's helpful. Here's the part about this that is going to be maybe a little bit off, is the fact that right now, I have enough to be able to kind of tell you what's going on, but I don't have this last square. So this negative 15 is what I'm going to keep out over here. I'm already, because it's a negative, I'm already 15 short because I've got that minus 15. I'm going to have to figure out what I still need. I'm going to be short both of those, because if I'm already in a negative and I need more in the positive here, these are going to be ones that I actually have to take into account as well. So let's think about what this is going to be. So this is x and 3, this is x and 3, this is x and 3, this is x and 3. So what that's going to mean then is to fill both of those in, I'm going to need 3 times 3, which is 9. Same thing here, 3 times 3, which is 9. So I don't have either of those yet. So I am, from the first one, 9 short, and from the second one, 9 short. So all told, when I look at those, I am 15 and 18 is 33 short total. So I'm minus 33. Okay. Well, I mean, it's helpful for me to be able to put that on there because this number is always just going to get tacked on at the end. What I have with these, though, is they're set up in such a way that they're both the same thing. So I'm going to have x plus 3 squared. And because I've got 2 of them, I've got to put that here. Then that minus 33 is going to sit right there. So that takes into account that part. And so the equation is that y is equal to that. That is the square completed for that whole thing. Now, what that means is that the vertex is going to be, for the x part, a negative 3, and for the y part, a negative 33. And that's fine. In the case of something like this, negative 3 and negative 33 is fine. It wants the x coordinate, so that right there, that's our x coordinate. All right, cool. Continuing. Oh, Anita, she's representing this described in the table. She wants to convert it to vertex form. She knows how to rearrange the tiles. They're all positive. So we're actually not starting off short here. That's actually kind of nice. So let's think about this. We've got 3 diagrams because of a 3x squared, which is cool. So I'm going to draw that over here. We will have x squared, x squared, x squared. Okay, cool. Now, how many x tiles will go into each diagram is the next one. Well, if I've got 3 diagrams for that number, for this one then, I need to take that and divide it by 3 to figure out how many is going to be in each. So that means I'm going to have a total of 4 x's in each diagram. So 4x. And the reason for that is because of the fact that it is the 12 x's divided by the 3 diagrams. Now, if I'm going to do that then, if I've got 4x that's going to go into them and I have to split them, what are the length and width of each diagram? I'll do that in a second. This here is going to be 2x and 2x for all of them, because if each of them get 4x, I've got to split them in half. Here's 2, here's 2, here's 2, here's 2. Okay, 2x, 2x. Great. So the length and width of each diagram, well, that's basically just me saying what's going to be out on the side. So this will be x and 2, x and 2. That is all of them, right? x2, 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 x2. So length and width of each diagram is x plus 2 for both. Now, I need the vertex. All right, well, we'll deal with that in just a second. So right now, once I've got all the diagrams made, but I still don't have the square completed, I need to be able to figure out what number needs to be in place to complete all three of these squares. 2 times 2, it'll be 4 for all of them. So what that means here is that I need 4, 4, and 4. I need 12 to make that happen. Well, here's what's great. Got 20. So I actually have everything that I need already. I can fill this in, but I'm going to have some extra. So I have 20 minus the 12. I have 8 extra, or plus 8. Cool. Well, what's nice about that is now I can just write my equation because each of these is x plus 2 squared. So what I'm going to do first is write the vertex form, and we can figure out what's going to happen with that. So it'll be this. X plus 2 quantity squared. That plus 8 is the thing that I'm going to have right here because that's how many I have extra. And this is y. One thing I'm missing is how many diagrams I have. So I get 1, 2, 3 of these. So I'm going to have a 3 right there. 3x plus 2 squared plus 8. So the x-coordinate of the quadratic is x equals -2, because that's the number that goes in here. Now, here's the part about this that's really interesting to me. The fact that this is the x plus 2, and I need it right there to have a -2, I actually could have already done that because of the length and width of each diagram if I wanted to. I could have done this without writing it in the format. This just gives me more information. So when they ask about how many unit squares are needed to complete the diagram, when we completed the square, we kind of already did that. So I need 4 total, 4 per diagram, or 12 total. And then they ask, what's the y coordinate of the quadratic? Well, they're basically asking you to figure out how many extra you have, which we already did. So that means that here, my y coordinate is going to be y equals 8, because my vertex is going to be -2, 8. All right, it's got a lot of good stuff there. One more page, which is more than I kind of expected for us to do on this, but that's okay. All right, last one. Oh, Anita. I don't know why Anita is the person that's dealing with this. It's fine. Oh, we're doing it in general. Has A, x squared tiles, B, x tiles, and C, unit tiles. How many diagrams should she make? A diagram. How many x tiles will go in each diagram? Well, if we think what we did, we took whatever that number was for the number of tiles, and we divided it by how many diagrams I had. So we would need B divided by A. All right. How many of those x tiles are needed for the width and the length? Okay, so let's think about that. We were talking about what we were going to need. So let's do this for just a second. Each time I'm doing that, the width and the length, we would take this and figure out how many I would need in each of the tiles themselves. So I would have some sort of x squared, and I would have some amount here and here for each of my diagrams. Those diagrams there, since I have B over A total for each of the diagrams, and I have to split it in half, that length that's going to be there is this divided by 2. Okay, because that's the width and for the length if I'm doing the x tiles. So this would be B over A. Nope, that's an 8, sorry. Divided by 2, which is actually the same as B over 2A. Because dividing by 2 is the same as multiplying by half. So it's like putting a 2 on there. Okay. What is the length and width of each diagram? All right, I'm going to just go over here for a minute. Each diagram has an x squared. In this case right here, we would have B over 2A x. And here I would also have B over 2A x. So the length and width of each diagram would be an x and an x. And then here it would be B over 2A, right? Just based upon the way that I had done this before. So the length and the width would be x plus B over 2A here and here. So when I have that as a part of the vertex form, just, because this is the way that I was doing it before, I'm going to just write this down. you know what? Let's worry about it in a minute. X coordinate of the vertex of the quadratic, then we did this from before. We said we could have figured it out by just saying here, the vertex is going to have negative b over 2a, because that's what I'd plug in here to make this 0. I still don't know what this one would actually be. So, this is only because I'm doing this. So I'm going to kind of keep working through it, even though it doesn't ask me to, because I've kind of done the work already. If I had to complete this square here, I'd multiply this times itself. So I would need b times b, which is b squared, and 2a times 2a, which is 4a squared. Okay. So if I'm writing this in vertex form, I need that. So I need b squared over 4a squared unit tiles. I have c unit tiles. So really what I'm looking to see in terms of how many I'm going to actually need, because I don't know if these are positive or negative. Let's think about what we were doing with that. So here we had 20, we needed 12. So I subtracted those two and I got 8 was my extra. Okay. Looking here, I had 43, I needed 36. So 43 minus 36 gave me 7. I had negative 10, I needed 42.25. So I took that number and I subtracted 42.25, which gives me that negative. Okay, so if I take the number I have and I subtract the number I need, that should tell me what I am going to actually need. So here, if I have C unit tiles, I will need C minus B squared over 4A squared tiles. So I am going to have this is the amount that I'm looking at in terms of what should be at the end of my vertex part. So this is the part that I'm going to be adding. Now, it's possible that this is negative, so I'd be subtracting it, or it's possible that it's positive, and I'd be adding it. So if I have extras, because this is smaller than this, it's fine. That'd be positive. If this is bigger than this, then this will be negative, so I'd be subtracting. So it works for either situation. That means that the vertex form of this, this is going to be weird and ugly, would be y equals, I have an a on the outside of that. I would have x plus b over 2a squared plus c minus b squared over 4a squared as that little extra piece there, which means that that would be my y coordinate. So if I did want to write it, I'd put that right here, c minus b squared over 4a squared. Now, guys, that is a little hard to figure out, but we've kind of gone through all of it. It didn't ask you to do all this extra stuff. So everything I did in orange is actually something you didn't need to do, but I figured that's enough to kind of give you an idea to what you have to do. So with that, I'm going to stop the recording.